Okay, welcome to dynamics. Okay, the first thing we look at is the difference between mass and weight and defining them. So the first thing is, what is mass? Okay, so this is essentially a body's resistance to a change in motion. Okay, so the larger your mass, the harder it is to make you go faster or slower, and also the harder it is to change your direction. We're trying to stay away from the idea of amount of matter because that's probably better defined as the mole. Inertia is sometimes related to mass, or said to be related to mass, and you could say that mass is like the measure of inertia. And it's the same thing, okay? Effectively, if you have a thing of a large mass travelling along, then it's hard to change its direction or get things moving. So if you look at the images below, so for this one down here, you've got a man with some sort of wire M-shaped object on his head and two large masses at the ends. Now on that one there, if you turn your head, the masses resist the motion, and so they'll stay where they are. With the classic tablecloth trick, which is here done with a coin and a piece of card, if you pull the card out, the coin will fall down because the coin's mass will resist its motion and effectively want to stay where it is. If we have a look at this load here attached with two pieces of string, if we pull this thing very quickly, okay, grab it and pull as fast as you can, then the string is going to break at B because the load is going to resist the motion and effectively protect A from that sudden motion that you've done when you've pulled down on the string. This is opposed to weight. Now weight is actually a force, okay, so mass is a property of a body. It does not push in any direction or anything like that. So mass is just a property that you have, it's a scale of quantity, whereas weight is a force that is acting on a mass due to a gravitational field. The formula for weight is W equals mg, where m is equal to mass and g is equal to the gravitational field strength. Okay, and that's usually measured in newtons per kg, and mass is measured in kgs. The unit of weight is the newton. And is it a vector or scalar? Well, it's a force. And so because it's a force, it must be a vector. There's some misconceptions with weight, okay? This way is a good example of how to sort of get past these misconceptions. If we have a dumbbell, okay, sitting on the ground, and we try to lift it up, it feels very heavy, okay? Now what we're doing, we are actually trying to move it against its weight. Okay, so force versus force. You have to have a larger force than the other force to move it in the direction you want. So the upwards force provided by you needs to be larger than the weight force going down. So you need to overcome it. You need to be better than that weight force to lift it. However, if you roll it, this isn't necessarily true we're talking about, but this is just a basic example. If we try and roll it, we're going to push it along. We're actually trying to overcome its mass, or more specifically its rotational inertia. But let's just call it mass. So we're trying to overcome the thing's mass. Now it's easy to make the thing move by rolling it. Much easier than lifting it. And in fact, you don't have to have a force larger than the mass, the magnitude of the mass, to be able to move it. Any force will almost do. Okay, the only time that the force wouldn't be able to move it is if there was too much friction for some reason. There's a deep carpet or something like that. Okay, so any force will make this thing move. All the mass does is it just determines how quickly it will speed up. In other words, it will resist the motion. It will resist how quickly it'll accelerate. So weight is a force you have to actually beat, whereas mass, anybody can overcome the size of mass to beat it. Okay, just a quick example for weight. Okay, so weight on the Earth and the Moon. So let's say I am 80 kgs, that's usually the estimate for a person. Okay, so weight on Earth will be the mass times gravity for Earth, so it'll be 80 times 9.81 for Earth. Okay, whereas if you're on the Moon, it'll be weight equals mass times gravity, but the gravity on the Moon is 6 times less, so we'll divide that value by 6, and we'll just do 80 times 9.81 over 6, and you'll get a new value. And both of those are in newtons.